Alright, so in this video we're talking about absolute or conditional convergence. Now a series converges absolutely if the series A of n converges, or if the absolute value of the series converges, then the series also converges. For conditional convergence, we have A of 1 is, or well, we already said this first one. So if the absolute value of a series converges, then the series is absolutely convergent, and it's conditionally convergent if just the series converges, but the absolute value of the series diverges. If the series converges, the absolute value diverges. So for our first one here, we're using the nth term test. And by the nth term test, remember you're taking the limit. We concluded for this one that the series diverges. The next one here, we have negative 1 to the n over root n. This one converges. It's an alternating p-series. But if we throw it in an absolute value, it will diverge. So this one is conditionally convergent. My next one here, very important, this is not alternating. It might seem that it would, but this one does not alternate. So we're going to use a ratio test here. Or well, no, we're just going to see if our series, or what our series does in the first place. If we are simplifying this a little bit, your simplification will take you to 1 over 3 to the n, which is a convergent geometric series. And because of the absolute convergence theorem, if the absolute value of a series converges, the regular one also converges, which means this one also converges, and I'm off the screen. So our absolute value one converges, so by our absolute value convergence theorem, the regular one also converges, which means these are absolutely convergent. And our last one over here, this one is an alternating series, so we can use the alternating series test. If we do that, we find out it converges, the regular series, but the absolute value here of our series diverges by comparison test, which means that this series is conditionally convergent. And there we go.